Hi everyone, how are you all? So in this session, we are going to study pigeonhole principle. Okay, in combinatorics, this pigeonhole principle we are going to study. So let's start. Let me tell you that this is very easy to understand principle. So in the complete combinatorics, in this combinatorics, we have seen a lot of principles we have seen. Okay, product rule, inclusion, exclusion principle, generating function, recurrence relation, a lot of concepts we have seen in combinatorics, right? But let me tell you, the most easy to understand, the most simple to understand principle is pigeonhole principle. Okay, so you will see this is very obvious principle, I can say, very obvious. Now, but the point is, this is difficult to apply. Okay, so if anyone asks you in the combinatorics, in the mathematics, which rule, which principle, which concept is easy to understand but difficult to apply, the answer is pigeonhole principle. Okay, so let's start. But we will see a lot of questions. We are going to see all the standard questions. We will see each and every gate question we will see. Okay, so this pigeonhole principle will become very easy for you by the end of this session. So let's start this session now. Okay, so let's start what this pigeonhole principle says. This pigeonhole principle, this is all about, can you guarantee something? Okay, please understand that this pigeonhole principle, this talks about that, can you guarantee some event? Something will happen. Can you guarantee? Can you give a guarantee that something will happen? Okay, so this is very important, that can you guarantee that something will happen? This is what pigeonhole principle says. So let's see with example. Let's consider this example. Assume that you have 4 pigeons and there are 5 pigeonholes. Okay, so it's like there are 4 people and total 5 rooms are there. So can you guarantee that at least 2 people will go to the same room? Can you guarantee that at least 2 pigeons will go to the same hole? Can you guarantee? In this situation, can you guarantee? Focus on this word guarantee. Means you have 4 pigeons. There are 4 pigeons. Let's call them P1, P2, P3, P4. And there are total 5 holes are there. Okay, there are total 5 holes are there. Now you tell me, can you guarantee that at least 2 of them will go to the same hole? Okay, can you guarantee? See, it is possible they can go, right? It is possible. For example, maybe this P1 also goes here. This P2 also goes here, right? It is possible. Agree with me that there is a possibility that they can go to the same hole. There is a possibility. Okay, so this possibility is there. For example, maybe P3 goes here and maybe P4 goes here. So there is a possibility, but there is no guarantee. This is a possibility. I can say this is a possibility. I'm saying that this is a possibility, but there is no guarantee. There is no guarantee, but this is a possibility, but not guarantee. But not, I can say, guarantee. Okay, so this is the point. Now you can see, maybe you cannot guarantee. Why? Maybe this happens that P1 goes here, P2 goes here, P3 goes here, and P4 goes here. Now you can notice that 2 pigeons, at least 2 pigeons are going to the same hole. At least 2 pigeons, they are going to the same hole. So this we cannot guarantee. Agree? Is this point clear to everyone? So you can easily notice, can we guarantee that at least 2 pigeons will go to the same hole? The answer is no, we cannot guarantee. Okay? Very simple. They may or may not go to the same hole. They may go to the same hole. Okay? At least 2 pigeons, they can go to same hole. There is a possibility, but there is no guarantee. It is possible that they are going to different holes. Okay? Now let's see another example. Consider this one. You have 4 pigeons and 4 holes. Now can you guarantee? You have 4 pigeons, P1, P2, P3, P4, and there are 4 holes. Now can you guarantee that? Can you guarantee, this guarantee word you focus, can you guarantee that at least 2 pigeons will go to the same hole? Can you guarantee? Again, you cannot guarantee. Again, you cannot guarantee, because maybe what can happen? Maybe this is going here, maybe this is going here, maybe this is going here. And so you can notice 2 pigeons are going to the same hole. This is not guaranteed. So again, you cannot guarantee. It is possibility, right? Agree? Maybe all of them are going to the same hole. Maybe all of them are going to the same hole. So this is a possibility, but this is not a guarantee. Okay. This is a possibility, but not a guarantee. We cannot guarantee that this will happen. Okay. So very simple point. I hope this point is clear. So you cannot guarantee. Now let's see this example. You have 4 pigeons and 3 holes. Now you tell me, now can you guarantee that at least 2 pigeons will go to the same hole? Okay, now can you guarantee? See, you have total 4 people and you have only 3 rooms. These 4 friends, they go to a hotel. In this hotel, there are 3 rooms. Now what they need to do? At least 2 people need to share a room. Agree with me? Yes or no? At least 2 people need to share a room. Whatever you do, see, whatever you do, because these are the 4 friends, they are going to a hotel. In this hotel, there are 3 rooms. So whatever you do, at least 2 people, they have to share a room. Okay. So for example, maybe this person goes here, this person goes here, this person goes here. Now where this 4th person will go? Now where this 4th person will go? This person has to, basically, at least 2 pigeons have to share a room. Agree? You can notice, at least 2 pigeons, they have to share a room. Okay, whatever you do, for example, maybe all of them are going to the same room. Maybe all of them are going to the same room. Now, is this statement true? Maybe all of them are going to the same room. Now, is this statement true? That at least 2 are going to the same room. Is this statement true? At least two are going to the same room. Here also this statement is true. Here also this statement is true. See, whatever you do, this statement will be true. You can do whatever you want. For example, maybe this pigeon goes to this hall, this pigeon goes to this hall, this pigeon goes here, and this pigeon also goes here. Now again you can notice. So whatever you do, at least two pigeon will definitely go to the same hole. Okay. So whatever you do. So can you guarantee? The answer is yes, you can guarantee. Okay. Yes, you can guarantee. Very simple. I hope this point is clear. So can you guarantee? Because you have more people. It's like 4 people. You have four friends are there and there are 3 rooms. So in this situation, I can say guarantee at least 2 people will share a room. At least 2. Maybe all of them will share a room. Maybe all of them will go here. Okay. Maybe 3 will go here. But the point is at least 2 will definitely go to the same room. Means at least 2 will definitely share a room. Okay. At least 2 people, they need to share a room. So this is the point. Now tell me about this question. You have 4 pigeons and 2 holes. Now can you guarantee that at least 2 will share a hole? Now tell me. 4 pigeons, 2 holes. Now can you guarantee that at least 2 pigeons will go to same hole? Again the answer is yes. Again the answer is because there are more pigeons. There are more pigeons and there are less number of holes. It's like there are 4 friends and there are only 2 rooms. There are 4 friends and there are only 2 rooms. Now again you can notice that at least 2 pigeons, they need to share a room. Whatever you do. For example, maybe these 2 pigeons will share a room. Maybe this pigeon will also go here. Maybe this pigeon will go here. But the point is at least 2 pigeons will share a hole. Okay, so very simple. Whatever you do, this will happen. Maybe all of them will go here. Maybe. But the point is, whatever you do, at least 2 pigeons will go to the same hole. So I hope this point is clear. So did you understand that if you have more number of pigeons, remember, if you have more number of pigeons but less number of holes, so pigeons are more pigeons than holes, then in this situation, can I say at least 2 pigeons will have to share a room? At least 2 pigeons will have to share a hole. Agree? So you can notice if you have n pigeons and there are n pigeons are there and n pigeon holes are there where pigeons are more than holes. Okay. Means people are more than the number of rooms. Then in this situation, at least 2 people need to share a room. At least 2 people, at least 2. 2 or more, at least 2 pigeons will have to share a room. I hope this point is clear. Very simple, right? This pigeonhole principle, isn't it obvious that you have 5 people and there are 4 rooms? So at least 2 people need to share a room, right? At least 2 people will go to the same room. Okay. So whatever you do, very simple. So how can you prove it? Let's see how to prove it. If you have total m pigeons, n pigeon holes, where m is greater than n, means pigeons are more than the holes. Now, at least means I can say there is at least 1 pigeon hole, there is at least 1 room with 2 or more pigeons. With 2 or more pigeons, there is at least 1 room, there is at least 1 hole with 2 or more pigeons in it. So how you can prove it? Tell me. Anyone want to tell me how can you prove it? Let's see what is the proof. So let's see the proof like this. Read this. This is a guideline, and this guideline we are going to use many times. See, if I tell you that some event will happen for guarantee, if I give you a guarantee that something will definitely happen, okay, if I give you guarantee that something will definitely happen, then what you will do to solve this type of question? I tell you that some event will definitely happen, Then what can you do to solve this type of question? The best way to solve questions which ask for guarantee of some event, the best is try to prevent this event from happening. Yes or no? Is this point clear? Very simple. If there is a question in which the question is asking for guarantee of event X, the question is saying that event X will definitely happen, then what is the best way to solve this type of question? That is, prevent this event from happening. Try to prevent this event from happening. So let's do this. In this question, you have more pigeons and less number of pigeonholes. Means, for example, let's assume that you have m pigeons. Let's assume you have total n people you have, and let's assume there are total n rooms are there, and let's assume that m is greater than n. Now in this situation, how can you stop this from happening? We are saying that at least one room will have more than one people. Okay, see, can you guarantee that at least one room, means at least two people will go to same room. At least two people go to same room, will go to same room. Okay, so at least two people will go to same room. The answer is yes, but how can you prove it? How can you stop this from happening? Tell me. You don't want this to happen. We are saying that at least two people will definitely go to the same room, but you don't want this to happen. Okay, so how can you prevent? Remember, how can you prevent this event from happening? So make sure that in any room, at most one person goes. Agree? In any room, at most one person goes. Agree with me? So what you will do in this situation, you will make sure that these are the rooms. So you have, for example, I can say this is room number 1, room number 2, room number 3, and so on. Total room number n. Total n rooms are there. You know this. Okay, what you will try? You will make sure that in any room, at most one person goes. Agree with me? You will make sure that this does not happen. You will make sure that there is no room in which at least two people are going. You will make sure, you will try that two people don't have to share a room. Okay, two people don't have to share a room. So these are the people, P1, P2, P3, and so on, PM. Remember, these are the people. So you have m people. Okay, but remember, m is greater than n. Number of people are more. So, okay, now let's make sure that in any room, you don't put two people. At least two people you don't put. Means make sure that two people don't have to share a room. So what you will do? This P1 can go here. Agree with me? This P1 can go here. Can P2 go here? Can P2 go here? P2 cannot go here because we want to make sure, we will try to prevent two people from going to the same room. Okay, we are making sure that two people don't have to share a room. So let's assume that P2 goes here. Now, can P3 go here? No, because we want to make sure that two people don't have to share a room. Okay, this is a Corona time, maybe. Okay, Corona is going on. We want to make sure that two people don't have to share a room. So this P3 will have to go here. And so on. Tell me where this Pn will go. Ultimately, this Pn will come because m is greater than n. Because m is greater than n. So ultimately, this Pn will go here. Now, all the rooms are complete. Can I say all the rooms are filled? At this point of time, can I say all the rooms are filled? These people have occupied all the rooms. There is no room empty. We don't have any room empty. Now tell me where these people will go. Okay, definitely you can notice whatever you do, at least two people will have to share a room. Agree with me? Okay, where you will put these people. So definitely at least two people will have to share a room. I hope this point is clear. This is a simple, very, very obvious proof, right? Can you notice this statement is very obvious? This pigeonhole principle statement is very obvious. And the proof is also very obvious. Yes or no? Agree with me? The proof is also very simple, that you just make sure that two people don't have to share a room. So now you can easily notice these people, where you will put these people. What will happen to these people? So if you want to put these people, then definitely at least 2 people will have to share a room because m is greater than n. Okay, so I hope this point is clear. So this is the simple proof that if you have this type of situation, so we have seen the proof. We have seen the proof. Very simple. So if you have this type of situation where you have k plus 1 or more pigeons, means pigeons are more and pigeonholes are less. Okay, number of pigeons, that is k plus 1 or more, means number of pigeons is more than number of holes. This number of pigeons, this is more than number of pigeonholes. Number of pigeonholes. Okay, then in this situation, I can say at least one hole will have 2 pigeons. I can say at least one hole has 2 pigeons. I can say at least one hole has more than one pigeon. More than one pigeon. I hope this point is clear. Okay, very simple. At least one hole, at least one room will have more than one people. So very simple. This is the pigeonhole principle. I hope you understood. Now let's see this question. Consider this one. So you can see you have an office in which you have 13 people. So let's assume there are 13 people. Okay, you have total 13 people in a room or in an office. There are 13 employees. Can you guarantee that at least 2 of them will share birthday month? Can you guarantee? Can you guarantee this? I want to ask you guarantee. Can you guarantee that at least 2 people will have birthday in the same month? Birthday in the same month. Birthday in the same month. Yes, I can guarantee. See, very simple. Okay, what you will do to prevent this from happening? Only these are the months: January, February, and so on, December. Only these are the months. Only 12 months are there. Only 12 months are there. And you have total 13 people. P1, P2, and so on, P13. These are the 13 people. Now you can easily notice. At least 2 people will have to share the birthday month. Agree with me? Yes or no? Okay. Can you prevent this from happening? Let's try to prevent. Let's make sure that this does not happen. Let's make sure that no 2 people share the birthday month. Let's make sure that no 2 people have birthday in the same month. Okay. So let's make sure. If you make sure, for example, P1 has birthday in January, can P2 has birthday in January? Can P2 have birthday in January? No. We want to make sure that 2 people, okay, 2 people don't have birthday in the same month. We don't want that. So in this situation, this P2 will go here and so on. Where this P12 will go? This P12 will go here. Now, very obvious question, where this P13 will go? Very obvious question, where this P13 will go? So can you notice this P13, wherever it go, can you notice 2 people will share a birthday? At least 2 people will have to share a birthday month. Okay, I hope this point is clear. So very simple point. Is this point clear? That if you have total 13 people, then at least 2 people will have to share birthday month. Okay. Now tell me the same question if I ask you, there are 12 people. Now can you guarantee? There are 12 people. Now can you guarantee at least 2 people have same birthday month? Okay, now can you guarantee? I am asking now can you guarantee? Now can you guarantee that at least 2 people share birthday month? Tell me. Now can you guarantee? The answer is no. Now you cannot guarantee. Right? They may or may not. Agree with me? Did I say that they will definitely not share a birthday month? Did I say that? Okay. They may or may not. Maybe all of them have birthday in the January month. Agree with me? It is possibility. There is a possibility that all the people have birthday in the January month. But the point is, can you guarantee? This is the simple point. Can you guarantee? This is the point. So no, I cannot guarantee. Okay. Similarly, if you have, for example, 10 people, now can you guarantee? If you have 10 people, now can you guarantee? Now can you guarantee? Again, the answer is no. Now also I cannot guarantee that 2 people, at least 2 people At least two people, remember, at least two people will share birthday month. The same question if I ask you, if you have 20 people, now can you guarantee? Now can you guarantee? Yes, now I can guarantee. I can guarantee that at least two people will share a birthday month. Now, definitely I can guarantee. I hope this point is clear. So very simple. If you have greater than equal to 13 people, if you have greater than equal to 13 people, then I can guarantee. Then I can guarantee that this will definitely happen. Okay, let's see this. So very simple. If you have more pigeons, less pigeonholes. Okay, number of pigeons is more. Number of pigeons can be 4, 5, 6, 7, 8, 100. Number of pigeons can be more. Then whatever you do, remember, whatever you do, at least two pigeons will go to the same hole. Okay, so you can see 4 pigeons and there are 3 holes. So whatever you do, they will go to the same hole. You can see if you do like this, then also at least 2 pigeons are going to the same hole. If you do like this, then also at least 2 pigeons are going to the same hole. If you do like this, then also there is at least one hole with more than one pigeon. If you do like this, then also there is at least one hole with more than one pigeon. So the point is simple. At least one hole will definitely contain more than one pigeon. Is this point clear? At least one hole will definitely contain more than one pigeon. So very simple. This is the pigeonhole principle. Okay, so you can see. Because in the worst case, this is what can happen. But where this 4th pigeon will go, the number of pigeons is more. The number of pigeons is more than the pigeonholes. So in the worst case, 3 pigeons I can put in different holes. But where the 4th pigeon will go? So it's the simple point. Okay, now let's see. So this is the chicken holes. Okay, this is the chicken. Now, so let's move on. So let's see this example. Pigeonhole principle. This question, let's see. This is the example. If you have 27 English words, can you guarantee that at least 2 English words will start with the same initial letter? If you have 27 English words, I am giving you. What I am doing? I am giving you 27 English words. Okay. Before that, let me give you 10 English words. Now, if you have 10 English words, can you guarantee that at least 2 will start with the same initial? Is there any guarantee? Now can you guarantee that at least two words start with the same letter? Start with the same letter. Now can you guarantee? Start with same letter? The answer is no. In this situation, I cannot guarantee. Can you guarantee? The answer is no. Okay, because maybe this can happen. Maybe one word is starting from A, another word is starting from B, another is starting from C, and so on. Okay, and so on. I hope this point is clear. So very simple, like this. So can you guarantee that at least 2 words will start with the same letter? The answer is no, I cannot guarantee. Yes, this is a possibility, right? It is possible that I give you 10 words. I am giving you 10 words. It is possibility that 2 letters can start with the 2 words can start with the same letter. For example, maybe I can give you these 2 words. I can give you room. I can also give you rook. Okay, these are starting with the same letter. But the point is, you cannot guarantee. There is no guarantee. Now, the same question, if I give you 26 English words, now tell me, can you guarantee? Now, can you guarantee? I give you 26 English words. Now, can you guarantee? Again, there is no guarantee. Remember, again, there is no guarantee. Again, we don't have any guarantee, because maybe one word is starting like this, another word is starting with B, another word is starting with C, another word is starting with Z. So again, there is no guarantee. But if I give you 27 English words, now is there any guarantee? Now, is there any guarantee? Yes, there is a guarantee. Now you can guarantee, because now what will happen? See, these are the English words, W1, W2, and so on, W26, W27. These are the English words. Okay, what are the pigeonholes? Tell me, what are the pigeonholes here? The pigeonholes are the letters in English alphabet, A, B to Z. See, in this situation, can you make sure that at least 2 words don't start with the same letter? Is it possible? Is it possible that at least two letters don't start with same initials? Can you make sure that all of them are starting with different initials? The answer is no. Because what can you do? In the worst case, what can you do? What is the best you can do? If you want to prevent this from happening. Remember, this you don't want to happen. You want to stop it. So if you want to stop this from happening, then what you will need to do? You will need to make sure that all the words, they are starting with different letters. All the words, they are starting with different letters. Okay, no two words are starting with the same letter. So in this situation, this is the maximum you can do. But where this will go? Okay, so you can easily notice, you can guarantee that at least two words will start with the same letter. And the same situation will happen if you have any number which is greater than 26, right? If you have any number which is greater than 26, the same situation will happen. The same situation. I hope this point is clear. This is the pigeonhole principle. Very simple. Now let's see this example. Tell me here. If you have 366 people, can you guarantee that at least two will? Is there any guarantee that at least two will share the? I can say the date, the birth date. So you can see, if you have 366 people, then can I say this is a guarantee? The answer is no. If you have 366 people, the answer is no. Maybe these 366, maybe this is a leap year. Okay. See, maybe this is a leap year. Consider the leap year also. Okay, maybe this is the leap year. I give you 366 people and they all have different birthdays. Okay, from 1 January to 31st January. And you can see from 1 February to 29 February. And so on. I give you like this. Okay, 1 December to 31st December. I give you like this. Now you can notice, I can give you 366 people like this. These are the 366 people. I can give you, right? Agree with me? Is this point clear? If I give you 366 people, can you guarantee that at least two of them will have same birthday? Means at least two of them will celebrate their birthday on the same day. This is the question. If I give you 366 people, is there a guarantee? The question is about guarantee. Can you guarantee that at least two people will celebrate their birthday on the same day? The answer is no. You cannot guarantee. But if I give you 367 people, now there is a guarantee. Now there is a guarantee that at least two people will celebrate their birthday on the same day. At least two people will have the same birthday. Okay, because you can easily notice you have these many people, P2, P367. But maximum how many birthdays you can create? Maximum how many distinct birthdays you can create? Maximum how many distinct birthdays you can create? That is 366. That is the 366 birthdays are possible. So in this situation, you can notice that definitely at least two people will have to share birthday. Simple. I hope this point is clear. Okay. So very simple. This is the pigeonhole principle. What about this question? This is an interesting question. Please tell me the answer. How many students must be there in the class? How many students must be there in the class to guarantee? You want to guarantee, remember, you want to guarantee that at least two students receive the same score in a final exam where the marks that are given are from 0 to 100. Integers only. Consider only integers. Like don't give 9.5. Okay. Because if you give someone 9.5, what they will tell their parents? If you get 9.5, you will tell your parents that you got 10, right? Yes or no? If you get 9.1, then also you will say 10. If you got 9.9, then also you will say 10. This is what we do. Okay. So very simple. Now tell me. So consider only integers. Let's assume marks are integers. You can consider this as a GATE exam. Okay. So this exam you can consider as the GATE exam. In the GATE exam also you can notice, of course, in the GATE exam you can get negative marks also. Okay. For example, maybe some of you can get -5. Very talented student can get -5. Okay. So anyway, but the point is here. So how many students must be there in the class to guarantee? I want to guarantee that at least two students will get the same marks. See, what are the marks possible? Can you tell me? What are the marks that are possible? See, this is possible, this is possible, this is possible, this is possible, and so on. This is possible. So how many marks are possible? How many marks are possible? Tell me. So total, you can notice 101. I can say 101 pigeonholes are there. I can say 101 marks possible. Okay, 101 different marks possible. These many different marks are possible. So now you tell me a simple question I'm asking. If you want to make sure that at least 2 students go to the same marks, then how many students must be there? If you want to make sure, that at least 2 students, go to the same marks, at least 2 students go to the same marks, then how many students, at least how many students must be there? Like minimum, how many students must be there? 102 students, right? 102 students. Very simple. Because remember that if you have 101 students, then can you guarantee at least 2 will share the marks? If you have 101 students, let's assume you have 101 students. You have 101 students. So let's assume these are the students. Let's assume number of students is 101. Now, is it guarantee that 2 students will share the marks? Means 2 students will get the same marks. Is it guaranteed? No, this is not guaranteed. Maybe this student can get 0, this student can get 1, this student can get 2, and this student can get 100. So there is no guarantee here. Okay, there is no guarantee. But if I have 102 students, means these are the different marks possible. These are the different marks possible. Now, if I have 102 students, okay, at least 102 students. If I have at least 102 students, at least, there can be more students. There can be more students. But the point is, at least 102 students, if you have, then you can guarantee that at least 2 students will get the same marks. Agree? Now you can guarantee. Okay, now you can guarantee that at least 2 students will get the same marks. Now you can guarantee, because where it will go. Okay, so very simple. I hope this point is clear. So tell me, what is the answer for this question? How many students must be there in the class to guarantee? If you want to guarantee, then how many students must be there? At least 102. How many students? The answer will be at least 102. Now, if the question is asking for minimum, how many students? If the question is asking for minimum how many students, then the answer will be what? If the question is asking for minimum how many students to guarantee, the answer will be 102. Is this point clear? Okay, very simple question, right? So are you finding this pigeonhole principle very simple? This is a very simple principle, pigeonhole principle. Let's see this question. Consider a function from a finite set A. You have a finite set A to finite set B. You have a function where the domain cardinality is more than the codomain cardinality. Is it possible that f can be 1, 1? Is it possible? Okay, remember, for example, if you have a function from A to B, let's assume this A has 4 elements, and let's assume this B has 3 elements. This B has 3 elements. Now, you can easily notice that cardinality of A, that is greater than cardinality of B. In this situation, can you create one-to-one function from set A to set B? Is it possible? Is it possible you can create one-to-one function? Okay. Is it possible? One-to-one possible? Can it be one-to-one? Can it be one-one function? One-one function means different elements will map to different elements, right? Yes or no? One-one function means no 2 elements map to same element. Okay. This one-one function, this simply means different elements map to different elements. Different elements of A map to different elements of B. different elements of B. So you can see, can you create 1, 1? Let's try. Okay, let's try. Let's assume, okay, can you prevent, like, for example, let's try to make sure we create 1, 1 function. We try to create 1, 1 function. So this one is mapping to A. Now, can this 2 map to A? Can this 2 map to A? No, because I want to create 1, 1 function. Because the question is asking, is it possible? The question is asking, is it possible? The question is asking for possibility or guarantee. Tell me, the question is asking for possibility or guarantee. The question is asking for possibility or guarantee. The question is asking for possibility. And if the question is asking for possibility, then what you will do? Then you will try to create. Okay. Is this point clear? See, whenever a question is asking for possibility, okay, whenever a question in any subject, if the question asks for possibility of event X, then what you will do? And if the question is asking for guarantee of event X, then what you will do? What your approach will be? In any subject, this type of question can come. In any subject, operating system, algorithm, whatever subject you take, in any subject, this type of question can come. If the question is asking for possibility of event X, then what you will do? Because the question is asking for possibility of event X, then you will try to create. Yes or no? In this situation, you will try to create event X. You will try to create event X because the question is asking, is event X possible? So because the question is saying, is event X possible? So you will try to create event X. And if the question is saying, can you guarantee event X will happen? Can you guarantee that event X will definitely happen? Can you guarantee? Then what you will do? Then you will try to prevent event X. Then you will try to prevent event X. Okay. So simple. In this situation, you will try to prevent event X. Very simple. Agree or not? See, this is a general guideline. This guideline has nothing to do with pigeonhole principle. This is general. In operating system also, this type of questions will come. When you study deadlock, okay, in the deadlock chapter, this type of questions will come. In any subject, this type of questions can come. If the question is asking for possibility, is event X possible? Then you will try to create event X. If the question is asking, can you guarantee that event X will definitely happen? Then you will try to prevent event X. Simple. Okay, this is a simple guideline. So tell me, now I'm asking, is it possible? Can a one-to-one function possible? Is it possible that this function can be one-to-one? So let's try to create one-to-one function. So this one is mapping to A. So this 2 cannot map to A because I want to create one-to-one function. So this 2 will map to B. This 3 cannot map to B because I want to create one-to-one function. Now where this D will go? Tell me. Now what will happen to this 4? Where this 4 will go? This 4 has to go to some of these elements, right? Again, you can notice this is not a one-to-one function. Agree with me? So you can easily notice that. Can it be one-to-one? The answer is no. You cannot create one-to-one function. Is this point clear? That you cannot create one-to-one function. Whatever you do, you cannot create one-to-one function. Okay, for example, you can have maybe 2 elements. Now also cardinality of A is greater than cardinality of B. Now also you can notice you cannot create one-to-one function from A to B. From A to B, can it be 1, 1? Can it be 1, 1? Again, you cannot create because whatever you do, you cannot create one-to-one function. Whatever you do. Okay, can it be 1, 1? The answer is no. So can you notice this is also pigeonhole principle? Can you notice that this is also pigeonhole principle? That if you have function from set A to set B, where set A is finite, this is a finite set, okay, and such that the set A cardinality is greater than set B cardinality. Now in this situation, F cannot be 1, 1. F cannot be 1, 1. F cannot be 1, 1. Okay, and this is by pigeonhole principle. By pigeonhole principle. Why pigeonhole principle? Because at least 2 pigeons will go to the same hole, right? Here, who are the pigeons? Who are the holes? Who are the pigeons? Who are the holes? Now here, this set is the pigeon. This set A is the pigeon. They are going to these holes. They are going to these holes, right? Now you can notice there are more pigeons. 1, 2, 3, 4, 5. And there are less holes. So you can easily see that there are more pigeons, there are less holes. So at least 2 pigeons will go to the same hole. Okay, at least two pigeon will definitely go to the same hole. Whatever you do, at least 2 pigeons will definitely go to the same hole. Okay, so this is also your pigeonhole principle. Did you understand? This result is pigeonhole principle, because from set A to set B, set A is the pigeons. These pigeons are going to pigeonholes. Now you can see the number of holes are less, the number of pigeons are more. So definitely what will happen? At least two pigeons will share a hole. At least 2 pigeons will go to the same hole. So in this situation, I can say by pigeonhole principle, I can say this function cannot be one-to-one. You cannot have one-to-one function. So this is your final result. Okay, this is very simple result, that a function from a set with k plus 1 or more elements. See this, a function means mapping. A mapping from a set of k plus 1 or more elements to a set of k elements is never one-to-one. And what is the proof? The proof is by pigeonhole principle, right? Yes or no? The proof is by pigeonhole principle, because these are the pigeons in this situation. These will be the pigeons. You can see these elements are the pigeons. They are going to these are the pigeons. They are going to these holes. These are the holes. Number of pigeons are more. So definitely at least 2 pigeons will go to the same hole. If at least 2 pigeons are going to the same hole, so definitely this is not one-one function, right? At least 2 pigeons are going to the same hole. So definitely this is not one-one function. If this happens, then this is not one-one. This is not a one-one function. So this is a simple point. I hope this point is clear. Okay. I hope this point is clear. Now you tell me one more thing. Can you guarantee that it will be a on-to function? Can you guarantee? A simple question I'm asking. Pigeonhole principle, does it say that it will be a on-to function? You have a function from A to B where A cardinality is more than B cardinality. Pigeonhole principle is saying that it will be on-to. Does pigeonhole principle say that F will be onto? F will definitely be onto. The answer is no. Pigeonhole principle is not saying that it will be onto. Okay, because pigeonhole principle is not saying that it will be onto. Okay, maybe this can happen. Okay, so you can see this is not onto. Pigeonhole principle is not saying that it will be definitely onto. Pigeonhole principle is simply saying that at least 2 pigeons will go to same hole. It does not care about the other things. Okay, at least 2 pigeons will go to the same hole. At least two will go to the same hole. Maybe more. But at least 2 will go to the same hole. Yes or no? The pigeonhole principle is saying at least 2 will go to the same hole. Maybe more can go. Maybe all of them can go. Okay, very simple. But at least 2 will definitely go to the same hole. If this type of situation is there, A, B, and number of elements in A is more than number of elements in B. If this type of situation is there. So I hope this point is clear. So let's see this. So this is your pigeonhole principle. Again, I'm telling you, if you have m pigeons, n pigeonholes, where number of pigeons is more than pigeonholes, then at least one pigeonhole will contain more than 1 pigeons. Okay, at least 1 pigeonhole has to accommodate more than 1 pigeon. And the same statement, I can say that if you create a function with more than k elements, from a set of more than k elements to a set of k elements, then this will never be one-to-one. I hope this point is clear. So you can see, if you have a set which contains more than an object and you partition this into n classes, means you have a set which contains more than an object, and you partition this into n classes, then definitely at least one class will receive more than one object. So this is your pigeonhole principle. Very simple. You can check it out. Okay. In the pigeonhole principle, again, I'm telling you, this is a guideline. This is a guideline. If some question is asking for guarantee, okay, question is asking for guarantee of event X, then what you can do? You can try to prevent event X. Okay, simple. So let's see this question. Tell me the answer here. So the question is saying that if you have, see, okay, let's see this question. Tell me one thing. If you have a set, a question I am asking, you tell me, if you have a set which is a subset of positive integers, okay, which is a subset of positive integers, such that the set has more than, let's assume, more than 8 elements. Okay, this set has more than 8 elements. Now, can you guarantee that there will be at least 2 elements in S who have the same remainder when you divide by 8? Okay, is it guaranteed? So, is it guaranteed? See, I am asking, is it guaranteed that there exists A, B in this set S? Okay, there exists A, B in this set S, such that A mod 8, when you divide this A by 8, that is same as B mod 8. Okay, so means remainder is same when you divide by 8. Can you guarantee this? Can you guarantee this? Tell me. Means when you divide by 8, they will have the same remainder. Can you guarantee this? So remember, you have a set of positive integers. In this set, you have at least more than 8 elements. This S is a subset of positive integers. This S can be anything. I don't know what is this S. This set S can be anything. This is a subset of positive integers. Okay. In this set, you have more than 8 elements. Can you guarantee? Is there any guarantee that at least 2 elements, there exist 2 elements, there exist 2 different elements, there exist 2 different elements such that they will give you the same remainder when you divide by 8? The answer is yes. The answer is yes. Why the answer is yes? Can you prevent this from happening? See, your set has how many elements? These are the elements A1, A2, and so on, A8, A9, and so on. Means more than 1 element, more than 8 elements are there. Okay, this set S cardinality, that is more than 8. That is more than 8. Now you tell me, in worst case, how can you prevent this from happening? Tell me, how can you prevent this from happening? I want to make sure that no 2 elements, there are no 2 elements which give me the same remainder when I divide by 8. I want to make sure. Okay, I want to stop this because the question is saying, can you guarantee that at least 2 numbers, at least 2 different numbers are there who will give you the same remainder when you divide by 8? Now, I want to stop this. I want to prevent this from happening. So in the worst case, what I can do? In the worst case, what I can do? Remember, when you divide by 8, how many remainders are possible? Possible remainders when you divide by 8. What are the possible remainders when divided by 8? When you divide by 8. So what are the possible remainders? The possible remainders are 0, 1, 2, 3, and so on, 7. Total 8 possible remainders are there. 8 remainders are possible. Total 8 remainders are possible. These are the possible remainders. These are the possible remainders. Now you tell me, if these are the possible remainders, then I want to make sure that no 2 people have the same remainder when you divide by 8. No 2 people. In this set, there are more than 8 people. Okay, you can see there are more than 8 people. I want to make sure that no 2 elements give same remainder when you divide by 8. Then what I can do, maximum what I can do, this A1 can give remainder 0. This A2 can give remainder 1. This can give remainder. This can give remainder this, right? Yes or no? This can give remainder this. This is what can happen. I hope this point is clear. But what remainder this will give you? Tell me. Now tell me what remainder this will give you. Please tell me. What remainder this will give you? Now all the remainders are occupied. See, there are 8. See, these 8 numbers have taken these 8 remainders. Means these 8 people, they have taken these 8 rooms. Only 8 rooms are there. in the hotel, there are only 8 rooms. These 8 people have taken these rooms. So definitely this A9 will go to some room. Yes or no? Definitely this A9 will definitely, what it will do, it will go to some room which is already occupied. This A9 will go to some room which is already occupied. So what I can say? I can simply say that at least 2 people will share the same remainder. Yes or no? Is this point clear? So I can say, so if your set cardinality is more than 8, then I can say at least 2 people will share the same remainder. Then at least 2 numbers will have same remainder when you divide by 8. Will have same remainder when you divide by 8. I hope this point is clear. Is this point clear? That whatever you do, if you have more than 8 people, there are more than 8 people, then definitely at least 2 of them will share the same remainder. At least 2 of them will go to the same remainder. Simple. Is this point clear? So I can say if your set cardinality is more than 8, then at least 2 numbers will definitely have same remainder when you divide by 8. Can you make it general? Can you make this result general? Like for example, if your set has more than n elements, if your set has where n is positive integer, now you tell me, if your set has more than n elements, now how many elements you must have so that you can guarantee that same remainder will be there when you divide by n? Tell me, when you divide by n, then definitely same remainder you will get. At least 2 people will give you same remainder. Okay, yes or no? At least 2 people will give you same remainder. This is the general result. You can see this question. So you have a set of positive integers. Okay, so you have a subset of positive integers. You can see in this S, you have some positive integers. Do I know which integers I have? Tell me, is it given? Is it given what is set as? Is it given what is set as? No, it is not given. Set as can be any subset of positive integers. Set as can be, for example, maybe set as is like this: 23, 24, 99, okay, 108, for example, 217, 999, and so on. This set S can be anything. I hope this point is clear. But the point is this set S cardinality is equal to 37. Means there are 37 elements in this set S. This set S can be anything. This set S is a subset of positive integers. Okay, this set S can have any 37 values. Now, can I guarantee that at least 2 elements contain 2 elements that will give you same remainder when you divide by 36? When you divide by 36, then at least 2 numbers in this set, at least 2 numbers will give you the same remainder. Okay, because when you divide by 36, then maximum how many remainders are possible? Tell me, what are the remainders? What are the remainders by 36? Okay, 0 to 35. So 36 remainders are possible. Only these are the remainders possible. But you have 37 people. 37 numbers I have total in this set. There are 37 people, but number of remainders that are possible, that is only 36. Only 36 remainders possible. So definitely what? At least 2 people have to share the remainder. Yes or no? At least 2 people. This person, at least 2 people will have to share the remainder. Simple. So you have 2 elements that give you the same remainder. So very simple. Now let's move on. Now let me ask you some questions. Do you really understand pigeonhole principle? You are thinking that you understand. Okay, this pigeonhole principle is very simple. But let me tell you, use your common sense. This is very important in the pigeonhole principle. Okay, use your common sense. These questions that we are solving, solve them using your common sense. Okay, just visualize what is happening. Use your intuition, use your common sense. This is very important when you study pigeonhole principle. So let me ask you some questions. Tell me the answers. Please tell me the answer for this question. You have 6 pigeons and you have 4 holes. What can you guarantee? Which is true? What can you say? Which statement is true? You have 6 pigeons, you have 4 holes, pigeonholes. Now tell me, which statement is true? More pigeons than holes. Can I say at least 2 pigeons will go to the same hole? Of course. Of course, at least 2 pigeons will definitely go to the same hole. Can I guarantee that exactly 2 people will go to the same hole? Is it guaranteed that some hole will have exactly 2 people? Is it guaranteed? Is it guaranteed that option B will happen? See, can you create a counter example for option B? Can you prevent option B? Can you prevent option B? Can you prevent option B? Please tell me, can you prevent option B? Option B is saying exactly 2. Exactly 2 means not more than 2, not less than 2. Yes or no? Exactly 2 means not more than 2, not less than 2. Option B is saying that there is some hole with exactly 2 pigeons. Can you stop it? Of course I can stop it. Of course I can stop it. There are 4 holes. What I can do, I can put all the pigeons here. I can put all the pigeons here. Very easily I can stop. Yes or no? I can put all the pigeons here. All the 6 pigeons I can put here. If I put all the 6 pigeons here, is there any hole with exactly 2 pigeons? Is there any hole which contain exactly 2 pigeons? Not more than 2, not less than 2. So can you prevent option B? The answer is yes. I can prevent option B. So option B is not true. Option B is not true. Can you prevent option A? Can you prevent option A? I cannot prevent option A. Okay, this option A I cannot prevent. What about option C? Some hole has exactly 2 pigeons. No, this is also not there. At least 3 pigeons go to the same hole. Can you say that? Can you prevent option D? Can you prevent option D? Simple question. Can you prevent option D? Can you prevent option D? The answer is yes. Yes, of course I can prevent. What I can do? If I want to prevent option D, what I can do, because there are 4 holes, 6 pigeons, I can put P1, P2 here, P3, P4 here, P5, P6 here. That's it. Yes or no? That's it. I can prevent. 6 pigeons are there, 4 holes are there. I can prevent. So option D is also not true. Yes or no? Because option D is saying at least 3 pigeons will go to the same hole. But this is not true. This statement is not true. I can easily prevent. I can put 2 pigeons here, 2 pigeons here, 1 pigeon here, 1 pigeon here. So I can easily prevent option D. So option D is not true. Now let's see the question, this question. Tell me the answer here. Again, 6 pigeons, 4 holes. Again, the same question. At least 2 pigeons will go to the same hole. Yes. Okay. There will be some hole with at least 2 pigeons. Now tell me here. Exactly 2 pigeons will go to the same hole? No. Okay. What about this? What about this option? Some hole has at most 1 pigeon. What about this? Some hole has at most 1 pigeon. Some hole has at most 1 pigeon. Can you prevent option C from happening? Can you prevent option C? I'm asking, can you prevent option C? Try this. Okay, try to prevent option C. Take your copy pen. Take your copy pen and do it. Some students are watching it like a movie and those students are not getting it. I know. Those students will make mistake who are watching it like a movie. Try this. Can you prevent option C from happening? See, if you want to prevent option C, then what you need to do? See, option C is saying that there is at least 1 hole in which at most 1 pigeon is there. Okay, there is at least 1 hole with at most 1 pigeon. If you want to prevent option C, what you need to do? To prevent option C, what you need to do? To prevent option C, what you need to do? What you need to do? See, option C is saying that at least 1 hole has at most 1 pigeon. If you want to prevent option C, what you need to do? every hole has more than one pigeon? Every hole has more than or equal to two pigeons. Is it possible? Is it possible? Please tell me. If you see, if you make it blank, if you do this, for example, P1, P2, P3 you put here, P4, P5, 6, P6 you put here. Did I prevent option C? Did I prevent option C? This is at most one, right? Here I have at most one pigeon. Can I say? Can I say here I have at most one pigeon? Can I say this? Can I say here I have at most one pigeon? Can I say here I have at most one pigeon? Yes. Yes, I have at most one pigeon. Is this point clear? In this hole, I have at most one pigeon. At most one pigeon. Yes. So I cannot prevent option C. Here also at most one pigeon. So remember, now tell me, if you want to prevent option C is saying some hole has at most one pigeon. At least one hole has at most one pigeon. If you want to prevent option C, then what you need to do? Do you agree with me? This is what you need to do. That every hole should have more than one pigeon. That every hole should have more than one pigeon. Can I say? Every hole should have more than one pigeon. Is it possible? Every hole has more than equal to two pigeon. Is it possible? This is not possible, right? Because only 6 pigeons are there. Because only 6 pigeons you have. See, only 6 pigeons and only 4 holes. Can you put in every hole? Can you put 2 pigeons? Means in every hole, can you do this? I cannot do this. So tell me, option C is true or not? Yes, option C is true. Did you understand? This is a beautiful question. This is a very beautiful question. Many students, what they do, they by heart this. The statement option A, they will by heart. Many students, they will by heart this. Pigeonhole principle, they will remember, yeah, option A is true. But they will not focus on option C. Can you prevent option C? Can you stop option C from happening? You cannot stop option C from happening. So can I say option C is guaranteed? Can I say option C is guaranteed? Yes, option C is also guaranteed. There is a guarantee that option C will happen. What about this? At least 3 pigeons will go to the same hole. This is not guaranteed. Is this point clear? In this question, the beauty is option C. This option C is the beauty. Now let's move on. Tell me the answer for this question. Tell me the answer here. Again, 6 pigeons, 4 holes. Apply your intuition. At least 2 pigeons will go to the same hole. Yeah, of course. You cannot stop. At least 2 pigeons will have to share a hole because more pigeons, less holes. So the pigeonhole principle says that at least 2 pigeons need to share a hole. Okay, what about this? Some hole has at most one pigeon. This is also correct. Is this correct? That some hole has at most 2 pigeons. Some hole has at most 2 pigeons. Yeah, of course, this is also correct. See, if option B is true, then of course option C is true. Agree with me? If some hole has at most one pigeon, then that hole has at most 2 pigeons also. If in some room you have one person, then can I say in this room you have at most 2 persons? Yes. If this room is empty, can I say in this room you have at most 2 people? Of course. So option C is also true. What do you need to do if you want to prevent option C? Stop option C, prevent option C. What do you need to do? To prevent option C, what do you need to do? Tell me. See, option C is saying that there is some hole with at most 2 pigeons. Okay, so if you want to stop it, then every hole should have more than 2 pigeons. More than 2 pigeons. Is it possible? More than 2 pigeons. Every hole should have at more than 2 pigeons. This is not possible, right? This is not possible. Okay, so very simple. I hope these questions are clear. Now, are you understanding pigeonhole principle more clearly? That pigeonhole principle says, can you guarantee something? So again, now are you getting that if the question is asking for guarantee, what you will do? Now tell me, if the question is asking for guarantee, what you will do? guarantee of event X, if the question is asking for guarantee of event X, you will try to prevent it. Okay, then you will try to prevent. You will try to prevent it. Making sense, right? Yes or no? Making sense that if the question is asking that some event is guaranteed, then you will try to prevent it. Okay, very simple. Now let's see this question. What about this one? See, this is interesting question. If you have this set, then can you guarantee that at least 2 people will have summation equal to 10? See this. You have this set. You have this set. Okay, now the question is saying that whatever subset you create of size 6, see this set you have, but from this set, whatever subset you create of size 6, that will definitely contain, from this whatever subset you create of size 6, that will definitely contain 2 elements whose summation equal to 10. Whose summation equal to 10. Let me ask you this. If you have this set, let's assume these are the numbers from 1 to 9. Okay. Now tell me, I want this guarantee I want. From this I create a subset. Please understand the question properly, that from this I create a subset. I create a subset. And in this subset, I want this guarantee. In this P, I want a guarantee. What I want? I want a guarantee that there are 2 people whose summation equal to 10. Okay. In this P, I want a guarantee. In this P, I want guarantee. Okay. Remember what I want? In this P, I want to make sure. This make sure is same as the guarantee, right? Agree or not? I want to make sure that you have A comma B, that there exists A comma B such that A plus B is equal to 10. I want to make sure that this is what I want to make sure, that you have A comma B must contain 2 elements whose summation equal to 10. Okay. Where A is different from B. So this is the question. Remember, you have a set S. I want to create a subset P. This subset P I want to create, but this type of subset I want to create where I want to make sure that there are 2 people whose summation equal to 10. Means in my subset, I want to guarantee that there are 2 people whose summation equal to 10. This guarantee I want. Is this point clear? I want to create a subset in which I want a guarantee that there are at least 2 people whose summation equal to 10. Okay, this is my purpose. With this purpose in mind, can I create this subset? For example, size 1 subset, will it guarantee? Like if from this, if I create size 1 subset, will that guarantee? Size 1 subset will guarantee? Size 1 subset does not guarantee, right? For example, size 2 subset will it guarantee? Size 2 subset, will it guarantee? Size 2 subset P. Okay, there is no guarantee because maybe you can take these 2. Did I get 2 elements whose summation equal to 10? Did I get 2 elements whose summation equal to 10? No. So size 2 subset also I cannot guarantee. No guarantee. Okay, no guarantee. Now remember this simple point. Ultimately, how to solve this question? Very easily you understand. So minimum what size I want. So what should be the size of P minimum? Okay, my question is, what should be the minimum size of P? My question is, what should be minimum size of P? What should be minimum size of P to guarantee? What should be minimum size of P to guarantee? Okay, so this is what I want. Okay, remember, I want what should be the minimum size of P to guarantee this. Now remember this simple point. Ultimately, this is my set. Please understand, very simple. Once you understand, then you can solve the question. From this, I want to create a subset. I want to create a subset. In this subset, I want 2 people. I want 2 people whose summation should be equal to 10. Okay, I want A plus B equal to 10. I want this. Okay, so you just ask one simple question. You ask in this, which are the two people who can give you summation equal to 10, right? Agree or not? This is interesting that, see, in this P, I want two people who will give me summation equal to 10. This is what I want. Summation equal to 10 I want. Okay. So what I will ask, this question I will ask, in this, who are the pairs to give me summation equal to 10? So tell me, summation equal to 10, pairs to give summation equal to 10. Pairs to give summation equal to 10. Which pairs can give me summation equal to 10? For example, 1,9, for example, 2,8, for example, 3,7, for example, 4,6. Okay, so these are the pairs. Yes or no? These are the pairs who can give me summation equal to 10. Okay, in this question, whether to consider 5,5 or not, any subset of size 6 must contain two elements with summation equal to 10. Okay. So in this question, actually, you should not consider 5,5. Okay. Consider, actually, this, of course, more details should be given, two different elements. This should be given in the question that two different elements. This should be given in the question that two different elements. Actually, this is what I have given. See, I have given this. I have given to you. Means from this set, you create a subset in which you have two different elements whose summation equal to 10. Please understand. Okay, is this point clear? My set is 1 to 9. From this, I want to create a subset. In this subset, I want to create a subset. Remember, from this, I want to create a subset in which I want two people. I want two different people whose summation equal to 10. I want summation equal to 10. So a simple question I can ask, who are the two people who can give me summation equal to 10? And this is what you do in the real life also. Agree with me? See, if you have some problem, then this type of things you will do in the real life also. For example, let's assume you want two people who can do your work. You want two people who can do together, they can do your work. Then what you will do? In the world, you will go and you will search for combo of two people, right? Yes or no? You will see which two people are compatible. Agree or not? Let's assume you want two compatible people. Then what you will do? You will search for compatible people. Okay, very simple. The same thing is here. So first you find out which pairs are giving you sum equal to 10, because ultimately you want sum equal to 10. Ultimately, you want sum equal to 10. So just check it out. Which pairs are giving you sum equal to 10? So these pairs, these pairs, these pairs, these pairs. Okay, and there is one element that is remaining. One element that is remaining. So just put it here. Now you see. Now tell me. Now, if you want to guarantee that you get summation equal to 10, okay, can you prevent? How much you can prevent? Remember, how much you can prevent? So tell me. Let's try to prevent. Let's try to prevent summation equal to 10. Okay, try to prevent summation equal to 10. Try to prevent sum equal to 10. If you try to prevent sum equal to 10, then can you put 1,9 here? Can you put? Remember, I want to prevent, try to prevent summation equal to 10. So can I put 1,9 here? Can I put 1,9 here? No. What I will do? I will put only one of them. One of them I will put here. Maybe I can put 1. Okay. One of the, can I put both of them here? Can I put? No. I can put 2. Here I can put 7. Here I can put 4. And I can also put 5. At this point of time, do I have two different elements whose summation equal to 10? At this point of time, do I have A, B? Do I have A, B where A plus B equal to 10? No. Okay. No, I don't have. But if I add one more number, can I guarantee I will get summation equal to 10? If I add one more number, it does not matter which number. If I add one more number, can I guarantee summation equal to 10? Can I guarantee summation equal to 10? Are you getting my point? Please tell me, did you understand this? See, very simple point. I am saying that you try to prevent summation equal to 10. This is what you do. You try to prevent as much as possible. Okay, try to prevent this summation equal to 10. So you cannot put 1,9. If you put 1,9, then summation will come. Okay, the summation equal to 10 will come. So from here you can take 1, from here you can take 2, here you can take 7, here you can take 4, here you can take 5. At this point of time, I don't have two different people who will give me summation equal to 10. But if I add one more person, one more number if I put, then now I can guarantee that summation equal to 10. Okay, now I can guarantee. Now there is A comma B, where A comma B are different and their summation equal to 10. Okay, so tell me, did you understand that? I can say, what is the minimum size of P? So this is the final question. Your question was this: 1 to 9, these are the numbers. From this, I create a subset. Understand the question properly. From this, I create a subset. I want to make sure in this P, I want to make sure that there are two people whose summation equal to 10. I want to make sure that their summation equal to 10 and A comma B different. A comma B different. I want to make sure their summation equal to 10. Okay. And the question is asking, what is the minimum size of P to guarantee this happens? Okay. Minimum size of P to guarantee this happens. So what is the minimum size of P to guarantee this happens? Minimum size of P to guarantee this happens. To guarantee it happens. Okay, what is that? Minimum size of P to guarantee it happens. That will be 6. One more thing, very interesting. See, if you create any subset of size 6 or more, the point is this: from this set 1 to 9, whatever you do, if you create a subset of size 6 or more, of size greater than equal to 6, then definitely what will happen? Tell me. Then it is guaranteed. From this, whatever subset you create of size greater than equal to 6, then definitely this, you will have two numbers whose summation will be 10. Then definitely there exist A comma B whose summation will be equal to 10. Okay, you can try it. You can try this. But with 5, I cannot guarantee. Agree? With 5, I cannot guarantee this. The same thing I cannot guarantee with less than equal to 5. With less than equal to 5, I cannot guarantee. Okay, remember, with less than equal to 5, there is no guarantee. There is no guarantee that, okay, remember, there is no guarantee that there exists A comma B where summation equal to 10. Okay, for example, what is the counter example you will give? For example, you can consider this counter example where you can take 1, you can take 2, you can take 3, you can take 4, you can take 5. Now you can see, you don't have two different people giving you summation equal to 10. You don't have two different people giving you summation equal to 10. I hope this pigeonhole principle is clear. These examples, are they clear? Slowly we are taking complicated examples. Okay, slowly we are going to complicated examples. Now let's move on. Now let's see a very interesting problem. A very interesting problem in pigeonhole principle. This is, I can say, the most interesting question in the pigeonhole principle. If you study any book on the pigeonhole principle, any university article, okay, any chapter of pigeonhole principle, if you study, definitely you will find this problem. That is the reason I'm taking this problem separately. A very interesting problem, a very important also. Someday this problem has come in the GATE exam 2 times. And this will again come, definitely. Okay, so a very interesting problem on pigeonhole principle. And this is party tricks. Okay, so let me tell you that this same question can come in the GATE exam in many ways. The same question they can ask you in different ways. So let's see what are the different ways they can ask you the same question. So I have collected all the different ways I found on the internet to ask this same question. Remember, the question is same, but we are asking in different ways. So this is the question, read this. The question is saying, at a party, there are at least 2 people. There is a party. In this party, there are at least 2 people. Now people are shaking hands with one another. It is not necessary that every two people are shaking hands. Remember, people are shaking hands with one another, but it is not necessary that every two people are shaking hands. Prove that there are at least two people. Prove that there are at least two people who shook hands with exactly the same number of people. Means in this party, prove that there are at least two people who are shaking same number of hands. It's like they can shake hands with different people. Remember, they can shake hands with different people, but same number of people. For example, I can shake hands with two people, and you can shake hands with two different people, but you are also shaking two hands. I am also shaking two hands. So that number of handshake must be same. Are you getting my point? So at least two people have same number of handshakes. Is this point clear? Is this question clear? At least two people have same number of handshakes. In this question, when you read this question, then what will come to your mind? Whenever you see now from now onwards, in any question, whenever you will see this line, what will come to your mind? At least two things going to same. Please tell me what will come to your mind. Can you see where is pigeonhole principle hint? Where this hint is there, that this question you should solve using pigeonhole principle. Where is the hint? See, this is the hint. At least two people going to same something. At least two people going to same something, same number of handshake. Is this point clear? Let me know. See, sometimes we think, sir, how are you getting this idea that we need to apply pigeonhole principle? Sometimes we think like this, that I'm not understanding how you got this idea that we should apply pigeonhole principle in this question. How you got this idea? So I'm getting this idea from this line, that at least two pigeons are going to same something. Can you see? We need to apply pigeonhole principle here. Now the same question I can ask you in different way. The same question I can ask like this. You have a party with at least two people. Then there are at least two people. With the same number of friends at this party. Okay, in this party, there are at least two people, such that in this party, this has X number of friends, and this also has X number of friends within this party. Can you notice this question is same as the previous question? The same question they can ask you in different ways. You have a party in which you have two people, at least two people are there. And now there are at least two people in this party who have same number of friends at the party. Okay, who is telling you that you should apply the pigeonhole principle? Who is telling you in this question which words are shouting that you should apply pigeonhole principle? You can see at least two people going to same something. At least two people going to same something. At least two pigeons going to same pigeonholes. This is your Kenneth Rosen question. The same question in a different way. You have a party with at least two people. There are two people who know same number of people. Again, this is the same question like this. Here they are using the word friends, and here they are using the word know. Okay, so you can see there are at least two people who know the same number of people in this party. Okay, so very simple. Again, the same question in a different way. This is your Kenneth Rosen question. This question is from a university. Again, the same question. That there is a party. At least two people are there in this party. In this party, you can have many number of people. And now you need to prove that there are at least two people who know the same number of people. Okay, remember one point. Remember, in all these questions, knowing is not reflexive. In all these questions, you cannot consider that you know yourself. Okay, is this clear? In all these questions that I'm taking, you cannot consider that you know yourself. Like you cannot consider that you are friends with yourself. So just make sure that you don't consider yourself. Okay, you are not friends with yourself. You don't know yourself, something like that. Okay, now let's see this. And this is the theorem in graph theory. The same question they can ask you in the graph theory. This is the theorem that in a graph with at least two vertices, there are at least two vertices with the same degree. Don't worry about degree. In graph theory, you will study what is degree, but this is the same question as the previous one. You have a party, you have a graph, in which you have at least 2 people, and there are at least 2 people with the same number of friends. With the same number of friends. So the same question they can ask you in many different ways. You can see this is GATE Computer Science 2009 question. They are asking this question in the terms of graph. They are saying that you have a graph with more than 2 people. Means there is a party with more than 2 people. And the options are like this, that at least 2 people have the same degree. Don't worry about degree. I will explain what is degree. But the point is, at least 2 people, they know the same number of people. The same question has come in the GATE 1999 also. Okay, again, the graph has at least 2 vertices of same degree. Means the graph must have at least 2 vertices of same degree. So the same question can come in the GATE exam in many ways. So now let's see the solution. The solution is very interesting. Okay, so let's see this question. First of all, you tell me how to solve this question using pigeonhole principle or using inclusion exclusion, using which tool we should solve this question and how to know. Please tell me. So let's see the solution now. So you can see that this is the word. You have a party where you have at least 2 people. Now, there are at least 2 people who know the same number of people. There are at least 2 pigeons who go to the same pigeonhole. Is this point clear? So pigeonhole principle, that hint you are getting. In any question, whenever you see this type of thing, that at least two people are going to same number of something, then that is your pigeonhole principle. So let's apply the pigeonhole principle. Before we apply the pigeonhole principle, let's understand this problem. Let's understand. Let's assume there is a party. In this you have, let's assume there are total 6 people. In this party, we have total 6 people. Let's assume these are A, B, C, D, E, F. First, you understand this problem. Okay, let's understand. See, whatever you do, at least 2 people will have same number of friends. Whatever you do. At this point of time, in this current situation, tell me how many friends A has. How many, like for example, if A and B are friends, I will put like this. If A, B are friends, for example, let's assume A, B are friends. For example, let's assume A, D are friends. Let's assume F, E are friends. Let's assume B, F are friends. Now you tell me, at this point of time, how many friends A has? How many friends A has? 2 friends A has. B has 2 friends. D has 1 friend. C has 0 friend. E has 1 friend. F has 1 friend. Can you notice, at this point of time, at least 2 people have same friends, same number of friends? Can you notice in this party, at this point of time, at least 2 people have same number of friends. Like this also has 1 friend, this also has 1 friend. So at least 2 people have same number of friends. For example, this also has 2 friends, this also has 2 friends. So at least 2 people are having same number of friends. Okay. Now, at this point of time, how many? In this situation, how many? A has 0 friends, B has 0 friends, this has 0 friends, 0 friends, 0 friends, 0 friend. Now, can you notice? At least 2 people have same number of friends. They have same number of friends, right? This B has 0 friend, F has 0 friend. So they have same number of friends. Okay, is it clear? The same question you can understand like a handshake. For example, let's assume they are handshaking like this. Okay, let's assume. Okay, so now tell me here, how many handshake A is doing? How many handshakes A is doing? There are 4 handshakes. There is 1 handshake by C. There are 3 handshakes by D, 2 handshake by E, 2 handshake by F. And how many handshake B is doing? There are 4 handshake B is doing. Can you notice again, at least 2 people have same number of handshake? Again, at least 2 people have same number of handshake. See, whatever you do, you cannot stop at least 2 people from having same number of handshake. Whatever you do, that is your choice. Whatever you want. But the point is, you cannot stop. You cannot prevent 2 people from having same number of handshakes. Whatever you do. For example, here, see here, how many handshakes this person has? Can you notice this person and this person, they have same number of handshakes? Can you notice? This person has 3 handshakes. This person also has 3 handshakes. They have same number of handshakes. In this situation, this person has 3 handshakes. This person also has 3 handshakes. They have same number of handshakes. In this situation, these 2 people have same number of handshakes. See, this person has 4 handshakes. this person has 4 handshakes. See, are you getting my point? Did you understand the question? That whatever you do, at least 2 people will have same number of handshakes. At least 2 people will have same number of friends. At least 2 people will have same number of known. Is this clear? Now let's see how to prove it. See, whatever you do. For example, in this situation also you can notice at least 2 people are having same number of handshakes. In this question also, in this situation also, at least 2 people are having same number of handshakes. So whatever you do, this is the simple point. I hope you understood the question. Now, if you understood the question, let's apply the pigeonhole principle. Let's solve this question. So you have a party. Okay. In this party, there are, let's assume, n people. And this n is greater than equal to 2. So these many people you have in this party. Okay. And they are shaking hands. These people, they are shaking hands. In this party, some handshakes are happening. Okay. This is not necessary that every 2 people are shaking hand. Some random handshakes are happening. Random. Okay. Now you tell me, minimum a person can shake how many hands? Minimum a person can shake how many hands? For example, let me assume that I'm defining the number of handshakes a person can do. Let me call it degree. Okay, let me call this degree. Degree of a person A. What is that? Let me call it that number of handshakes A is doing. Is this clear? Number of handshakes A is doing. A had. Is this clear? Please tell me. What is degree of A? That is number of handshakes. How many handshakes A had? This word I am defining. This simply means number of handshakes. This simply means number of handshakes. For example, if I have this graph, if I give you this graph, A, B, C, D, E, and let's assume that A, B are handshaking, A, C are handshaking, these are handshaking. Let's assume these are handshaking. Okay. So let's assume this is the scenario. This is handshaking, this is handshaking, something like this. Okay, let's assume this is the scenario. Now tell me, how many handshakes A is having? What is the degree of A? Tell me, what is the degree of A? Degree of A means how many handshakes A has. Handshakes of A, that is 3. Handshakes of C, 2. Handshakes of D, 3. Handshakes of B, 2. Handshakes of E, 0. So handshakes of A, that is 3. Okay, what is degree of B? That is 2. What is degree of C? That is 2. Can you notice at least 2 people have same degree? At least 2 people have same degree. At least 2 people have same number of handshakes. At least 2 people, they have same number of handshakes. I hope this point is clear. So this word I'm defining, this degree word I'm defining, what I'm saying that this degree means, remember, this degree of any vertex X, that means number of handshakes of X. Number of handshakes of X. Okay, this is the simple point. Now, in this party, you tell me, what is the minimum degree and what is the maximum degree? What is the minimum degree and what is the maximum degree? Means a person can have how many handshakes? Minimum how many handshakes a person can have? A simple question. Tell me. Like if you take any, in this party, you take any particular person. In this party, there are total n people. N is greater than equal to 2. If you take any particular, a person X, if you take a person X, then for this person X, what is the minimum degree? What is the minimum number of handshakes it can have? Minimum degree means minimum number of handshakes it can have. Minimum degree means minimum number of handshakes. Okay, so tell me, what is the minimum degree? The minimum degree can be 0. And what is the maximum degree? What is the maximum degree? The maximum degree can be n-1. The maximum degree can be n-1. Agree with me? Okay, in this range, okay, this X can have 1, this can have 2, and so on. These are the possible number of handshakes. Agree? So far, is it clear? So far, is it clear that if you take any particular person X, then minimum number of handshakes is 0, maximum number of handshakes is n-1. Very simple. Okay, so this is the one thing. Now, something interesting. So how many handshakes are possible? Means these are the pigeonholes, right? Because ultimately what I want, ultimately I want that you have n people. These are the n people. P1, P2, P3, and Pn. Okay, I want to prove, ultimately, tell me what I want to prove. I want to prove that at least two people, they have same number of handshakes. Agree with me? Number of handshakes, or I can say degree, or I can call it number of handshakes. You can call it number of handshakes, or you can simply call it degree, or you can call it simply degree. But the point is this, that these are degrees possible: 1, 0, 1, 2, and so on, and -1. So tell me what the question is asking. Tell me what the question is asking. The question is asking that prove that at least two people will have same number of handshakes. Okay, yes or no? What the question is? See, the question is prove that at least two people have same number of handshakes. At least two people in this party, have same number of handshakes. Means at least two people have same degree. Okay, tell me, can I apply pigeonhole principle here? Can I apply like this P1 will have some number of handshakes, this P2 will have some number of handshakes, this P3 will have some number of handshakes. I want to prove that at least two people, they go to the same number of handshakes. I want to prove that at least two people, they go to same number of handshakes. Okay, at least two people are going to same number of handshakes. At least two people are going to same number of handshakes. Can I apply pigeonhole principle here? It's pigeonhole principle. Who are the pigeons? Who are the pigeons? See, these are the pigeons because they are going to pigeonholes, right? Yes or no? These people are the pigeons because they are going to the pigeonholes. These are the pigeons. And these number of handshakes, these are the pigeonholes, right? Did you understand? These are the pigeonholes. So how many pigeons are there? How many pigeons are there? N pigeons are there. How many pigeonholes are there? N pigeonholes are there. Can you apply pigeonhole principle? Can you apply pigeonhole principle? N pigeons are there. N pigeonholes are there. So can you guarantee that at least two people will go to the same number of handshakes? N people are there. N rooms are there. You have total N people and there are total N number of rooms. Can you guarantee that at least two people will share a room? Can you guarantee? No. So then how to prove it? So I cannot apply pigeonhole principle here. Then how to prove it? There is a trick. What is the trick? See, there is a very interesting trick. So right now you cannot apply the pigeonhole principle, but there is a trick. What is that? See. So you can see that it looks like you have N pigeons. And you have N pigeonholes. It is looking like that. Okay, it is looking like that. You have N pigeons and N pigeonholes. So it looks like pigeonhole principle is not applicable. Okay, it looks like. Now, but there is a trick. What is the trick here? This is an interesting trick. Is it possible that some person can have 0 handshake and some person can have N-1 handshake? Very simple. Is it possible? Just ask this question. Is it possible that some person can have 0 handshake? Some person can map to 0 handshake. Some person can map to 0 and some person can map to N-1. Can map to N-1 simultaneously. Simultaneously, is it possible? Just ask this question to yourself. Is it possible? Is it possible that some person is not shaking hand with anyone and some person is shaking hand with everyone else? Is it possible simultaneously? A very interesting question. See what I'm saying. I am saying that you have total 5 people. P1, P2, P3, P4. P3, P4, P5. These are the 5 people. These are the 5 people. Okay. And these are the number of handshakes. These are the number of handshakes. 0, 1, 2, 3, 4. These are the number of handshakes. Is it possible that some person is not shaking hand with anyone? Let's assume this is isolated person. This is introvert. or maybe this has corona. Okay, let's assume this has coronavirus. Now you tell me, is it possible that this person is going here, means this person is not shaking hands with anyone, number of handshakes of P1 is 0. Now is it possible that there is some person who can shake 4 hands? Can this P4 shake 4 hands? Tell me, this P5 can this P5 shake hands? See, he can shake hand with this, he can shake hand with this, he can shake hand with this, but this P5 cannot shake hands with P1. So is it possible these two can happen simultaneously? These two can happen simultaneously. This is never possible. Remember, this and this, these two can never happen simultaneously. Can never happen simultaneously. Can never happen together. Okay, is this point clear? These two things can never happen together, that there is some introvert person. This person is not shaking hands with anyone. The number of handshakes of P1 is 0. This P1 is not shaking hands with anyone. This P1 has coronavirus. Is it possible that P5 can shake hands with everyone else? This P5 can shake hands with everyone else. No, this is not possible. So these two things are never possible together. 0, n minus 1. They can never happen together. If they can never happen together, so what you can do? If they can never happen together, so you can create 2 cases. You can create 2 cases. Case 1, what is the case 1? If this happens, then maximum will be what? If this happens, if this is minimum, then what will be the maximum? The maximum will be n minus 2. Interesting? Are you finding this proof interesting, that if this is the minimum, if this happens, then n minus 1 cannot happen. If there is a person who does not shake hand with anyone else, there is an introvert person, there is a coronavirus person, then there is no person who can shake hands with everyone else. So if 0 happens, if this 0 happens, then n minus 1 cannot happen. And if this 1 happens, if this happens, then what cannot happen? If this happens, then what cannot happen? See, this happens means there is some person who is shaking hand with everyone. There is some person who is shaking hand with everyone. Okay, if this happens, then there is some person who is shaking hand with everyone. In this situation, 0 cannot happen. This 0 cannot happen. There is no introvert. Okay, there is no coronavirus here. If this person is shaking hand with everyone, then there is no person who is introvert. So very simple. There are 2 cases. Agree with me? Either case 1 or case 2. Only 2 cases are possible. Case 1, case 2. Now you tell me. Now can you say only 2 cases are possible? Now can you say n pigeons? How many pigeons? N pigeons. How many pigeonholes? How many pigeonholes? How many pigeonholes? N minus 1 pigeonholes. N pigeons, n minus 1 pigeonholes. So can I guarantee that at least 2 people will go to the same number of handshakes? Can I guarantee at least 2 people will go to the same number of handshakes? At least 2 people will go to same number of handshakes. Is this proof interesting? Are you finding pigeonhole principle interesting? Okay. See, these are the people in the party. In the party, there are n people. Now, you can guarantee that at least 2 people will go to the same number of handshakes. You can guarantee that at least two people will have the same degree. Degree means number of handshakes. Very simple. Degree means number of handshakes. So in this party, whatever you do, okay, at least 2 people will always have same number of handshakes. In this case 1. What about case 2? In this case 2 also, how many pigeons? In this case 2 also, how many pigeons? N pigeons. And how many pigeonholes? How many pigeonholes? Pigeonholes, that is n minus 1 pigeonholes. Okay, these are the pigeonholes. Again, the same thing. Will happen, that at least 2 pigeons will go to the same pigeonhole. At least 2 pigeons will go to the same pigeonhole. Okay, because more pigeons, less number of pigeonholes. So whatever you do, case 1 or case 2, whatever you do, ultimately I can say that at least 2 people will have same number of handshakes. Is this point clear? So I can say, so this is, we have proved. What we have proved? we have proved that at least two people have same degree. Whatever you do, it does not matter. Okay, okay, you can do whatever you want, but the point is at least two people will have same number of handshakes, will have same number of friends. The same thing you can write in many different ways. Will have same number of handshakes, or I can say will have same degree. Okay, I can say like this: at least two people will have same number of handshakes, or you can say at least two people will have same number of friends, or I can say at least two people will have same degree. At least two people will have same degree, or I can say at least two people will have same number of known people. Same number of known people. Can you notice? The same thing I can write in many different ways, but the proof is same. Is this clear to everyone? Let me tell you, let me know. Is this proof clear? Interesting, right? Okay. I'm saying that at least two people will have same number of handshakes. Here you can notice these three people are having same number of handshakes. Did I say that more than two people cannot have same number of handshakes? Did I say? No. Remember, at least two people will have same number of handshakes. Okay. You can have three people same number of handshakes. For example, in this example, you can notice F, D, C, they are having four handshakes. You can see D has 4 number of handshakes. The degree of D is 4. What is the degree of D? What is the degree of D? The degree of D is 4. You can simply see degree of F is 4. Degree of, what is degree of A? What is degree of A? Means how many handshakes A is having? A is doing 5 handshakes. Okay. Tell me how many friends E has? How many friends E has? How many friends E has? 3 friends E has. So can you notice that these people are having same number of handshakes? Okay. So at least two people will definitely have same number of handshakes. Did you notice this is the trick? This is the idea. This is the interesting idea, right? The interesting idea in this question was this, that these two buckets, can they be non-empty? Is it possible that someone will go here and someone will go here? Is it possible this bucket and this bucket can be non-empty? Is this possible? These two buckets can be non-empty. Means someone is going here, someone is going here. That is not possible. And this is the complete idea in this question. The answer is no. Okay, and this is very interesting idea. Using this idea, you can solve this question. So ultimately, how many buckets will be there? How many pigeons will be there? Whatever you do. See, either you can take 0 to 4, you can take, or you can take 1 to 5. But whatever you do, how many pigeonholes will be there? There will be only 5 pigeonholes, right? There will be 5 pigeonholes, whatever you do. Okay, whatever case you create, there will be 5 pigeonholes, either 0 to 4 or 1 to 5. But there are 6 pigeons. So more number of pigeons, less number of holes. So ultimately, I can say that at least 2 pigeons will share a hole. At least 2 people will have same number of handshakes. At least 2 people will have same degree. Now, can you solve these GATE exam questions? These GATE exam questions, can you try now? See, this theorem, did you understand? In any graph, at least 2 nodes will have same degree. At least 2 nodes will have same degree. The same proof. The proof is same. The proof we have seen. So can you tell me the answer for this question? What is the answer for this question? Tell me. In this question, what is the answer? So you have actually, don't worry, in the graph theory, you will study connected graph means there is no isolated person. Connected graph means there is no isolated person. Is this point clear? Connected graph means in this situation, connected graph simply means there is no degree 0 person. There is no degree 0 person. So in this question, what is the only possibility? What are the pigeonholes? In this question, what are the pigeonholes? There is no degree 0 person. I am saying that there is no degree 0 person. Connected means there is no degree 0 person. There is no isolated person. There is no isolated person because this is connected. So pigeonholes are 1 to how many? 1 to n minus 1. These are the pigeonholes. 1 to n minus 1. Okay. 1 to n minus 1. If you have n vertices. If you have total n vertices, let's assume, and the pigeons are n nodes. So ultimately you can notice at least 2 vertices will have the same degree. Okay, in the graph theory, this will become more clear. In the graph theory, this will become clear what is connected graph, what is undirected graph. But don't worry, I'm just telling you, once you study this concept in the graph theory, then you can solve this question using the same idea. This is what I'm telling you. Is this point clear? Once you study this concept, connected graph, undirected graph, once you study these concepts, then you can solve the same question you can solve using the same proof. Okay. And what about this one? Is it possible all can have different degree? Is it possible all vertices can have different degrees? Is it possible? If all vertices have different degrees, is it possible? So they cannot, right? All have different number of handshakes. All people have different number of handshakes. That is not possible. That is not possible. And we have proven it. The proof we have seen. Did you find this question interesting? I told you this question has come in the GATE exam many times. The same question has come in the GATE exam in many different ways. Okay, they can ask you the same question in many different ways. So this proof we have seen. Did you find this interesting and did you understand? Please tell me. Now, in the next lecture, we will study the generalized pigeonhole principle. Okay, so let's take a small break. And after the break, shall we start this or shall we start this tomorrow? Please tell me. This generalized pigeonhole principle, part 2. Shall we study today or shall we start it tomorrow? Please tell me. Okay, so just let me know. So we can study this. I think we can finish it today. Okay. So far, everything you understood. If you understood everything, then we can study today, or else we can study tomorrow. There is no problem. Okay. So let's study tomorrow. Okay. Let's complete it tomorrow. Is that clear? So today, whatever we have seen, please revise it. Okay. And tomorrow we will study this generalized pigeonhole principle. And tomorrow we will complete this pigeonhole principle. So far, did you understand everything? Please tell me. So far in the pigeonhole principle, did you understand everything? Everything, is it clear? So far, whatever we have seen, everything is clear? Okay, very good. So revise it. Okay, revise it. And tomorrow we will complete this chapter. This pigeonhole principle we will complete tomorrow. Okay. Thank you, everyone. See you tomorrow.